let's hear from Fluence, joint company of AES and Siemens, to which extent they see market potential in India already, or to which extent they're actually already working with clients. So Rupamji, over to you. Eager to get to know to which extent diesel gensets can be even replaced. And we are not talking about battery diesel genset hybrids only, but talking about pure PV battery systems, or even battery systems by itself for backup power. So over to you. Looking forward to your presentation.
Absolutely. Thanks, Tobias. All right, so I'll get started. So my name is Rupam Raja, and thanks for inviting me to speak on this session. I'm going to keep my camera off because I think we'll save some bandwidth. I'm working from home, and the bandwidth is not the best as you get at the workplace. I'm here to talk about battery storage and its applications in commercial industrial use in India. And I think some of it has been covered already. Tobias has made some very good points, and so has Vinay. So I'll just go into some more detail there. So I work with Fluence Energy. We are a joint venture of Siemens and AES. We have been doing battery storage for over 12 years now. Our first plant project was a megawatt scale plant commissioned in 2009, and it's still operating. We are currently in 22 countries. We have over 2,100 megawatts of battery storage under development or developed already. And that's the only thing we do. We are only about battery storage, and there's nothing else that Fluence does in the power sector. Of course, with our parents, it's a different story. Just a couple of accomplishments. We've been ranked #1 energy storage company by Navigant. We've been ranked #3 in the most innovative company by Fast Company. And if you look at our client list, which I have in front of you, we have some of the top tier companies in the world who we have deployed storage solutions for. So what is battery storage? I'll just give a quick overview. So basically, battery storage is, think of it as any typical power resource. The difference being that it's made out of batteries. That's the fuel in battery storage. So what you do is you take cells, you turn them into modules, you put modules on racks so that you have a compilation of battery cells. And then you put them inside an enclosure, you add power electronics on top of that, you control everything with the software. You have to have air conditioning so you can manage the temperature. And lastly, you need to put some safety elements, especially around firefighting. All of that together, when dispatched or charged in a predictable, safe manner, makes up what we call a battery storage resource. So having said that, Fluence has deployed a 10 megawatt 1 hour battery storage system in New Delhi. It's in northern Delhi. It's in the service area of Tata Power Delhi Distribution Limited, which is a distribution utility for the northern part of Delhi. What you're looking at is a battery storage system that was enclosed inside a civil structure. So this is actually a building. What you see on the left are the 4 transformers. Each of them is a 2.5 MVA transformer. The 4 of them add up to give you 10 MVA, and the duration is 1 hour. So that's something at the distribution company level, and I'm going to switch gears here because we are here to talk about commercial industrial. So I'm going to let you in on a little secret in India. So India has a total installed generation capacity of about 370 gigawatts, and that's massive. India has a peak load of about 180 gigawatts. And you would think that with almost twice as much installed capacity as peak load, India should not have any power outage problems. Well, you're looking at one view of the power outage that India faces. This is just the month-by-month view of the amount of peak demand that was not met. And you can see that the peak demand not met gets worse in the months of summer, April through July, which is when the northern plains start getting very hot, and then they start to get humid in July, and that's when the peaking demand goes up, and India's peak typically hits in the evenings, and even capacity, we are unable to meet that peaking demand, and that leads to basically peak demand not met. So needless to say, there are structural issues to why we have peaking power problems in the country. And just to kind of tell you a little bit about why that's happening, if you look at the pie chart on the left, I've shown what the generation mix looks like. You can see almost like 90 gigawatts is just solar and wind alone. And the problem with that is that in India, wind doesn't pick up till late in the evenings, and basically there's no sun available, once you're past like 4 p.m. And that's when the time in the evening when peak demand hits, basically the RE is mostly not available. So that takes about 90 gigawatts off the table, or a bulk of it. The second thing that's leading to the shortage is in the conventional thermal capacity, due to a variety of issues which I've listed on the right side, about 80 or 90 gigawatts of the firm capacity, thermal capacity, is not available. And that's because of cases like gas shortage, for example. India has a chronic gas shortage or a perpetual gas shortage problem. And that leads to a large fleet of the gas power plants not being fully available. We have issues with the coal shortage. India imports a lot of coal from Indonesia. We have opened up mining in the country, and we have power plants that are kind of captive. They have captive coal mines. Outside of that group of power plants, pretty much anyone else could potentially run into a coal shortage. The other reasons being technical faults, which leads to the unavailability, and the third big reason is just problems with scheduling, not being not calculating the demand ahead of time, and not getting the schedule right. Those can lead to power shortages as well. So the gist of it all is that if you are, and I understand that a lot of people on this call who are listening in either have operations in India already or plan to set up India operations, you will have to look at power backup. There is no way around it. And that's what I've discovered in my conversations with CNI sector. Everyone eventually needs power backup. So what's the most commonly used power backup source? The picture you're looking at is a very common site in India, in pretty much all of India, whether mainly urban as well as rural. And I'm not referring to the motorbikes. The motorbikes is a common site as well. I'm referring to the green box at the back. And the only thing green about that box is the color green, because that's a diesel generator. That's about a 2 megawatt generator. I just took that picture in a shopping mall right next to where I live. It's noisy, it's loud. You can see the smokestack on the right, so it's polluting. It has a dedicated space where they store diesel that feeds this beast. There's a team of people who's responsible for operating and maintaining this diesel genset. So that is the go-to option, regardless of whether you are an Indian company or a German company or an American company. Your backup power option is diesel. If Tobias talked about some numbers around how much diesel is engines are being sold in India. So I just compiled some data for diesel engines greater than 375 kVA, and that is the sector. That is the size that is almost entirely sold to CNI. If you go to sizes smaller than that, you have a big influx of residential users as well. So I'm keeping this focused on CNI. So to simply give a number, almost 7,000 diesel generators greater than 375 kVA were sold in India last year. In terms of dollar value, that's close to about $600 million just last year. This number is projected to go up. And it's projected to go up for a variety of reasons. First being, peaking power infrastructure is still lagging, so you'll still have the problem in the evenings when there's a lot of demand from people all around you, not just industrial, commercial, but residential as well. Most of the new capacity that India is adding is renewables, so that is solar and wind, and that does not help with the evening peak. We have some issues with our, especially our distribution infrastructure, and upgrading that takes time. So by the time help comes to where your factory is or where your manufacturing facility is, it could be a while before you get that help. And lastly, there's a policy focus on creating domestic manufacturing, and what that's going to do is it's going to create more demand, although that's not a problem right now. It will in the future, and eventually that's going to lead to peaking power shortages. So this problem is here to stay. If we look at what's the main option for backup power, it's diesel. I must tell you that diesel is facing some severe headwinds in India. And I'll just mention three. The first one being the price of diesel. So diesel was always looked at as poor man's fuel. It was highly subsidized. If you see the other fuel being petrol, you can see that over the last 8 years, 8 years back, diesel was about half the price of petrol. The price of petrol has remained the same over the last 8 years, and that's because of the global supply and demand. But the price of diesel is now almost as much as the price of petrol. So that is with the subsidies coming off. So basically, there's almost a doubling of a diesel expense if you're using diesel for whatever that use is. The second headwind is around EHS regulations. Indian cities are facing an air quality problem. The pollution levels have become really high, and that's not just true for Delhi. It's actually true for pretty much all of the 20 largest cities in the country. Now, diesel takes a bulk of that blame because there's so much diesel used for automotive as well as for energy applications. What has happened is more and more regulations are prohibiting the use of diesel when the air quality index is severe and when the pollution levels are high. So just to give you the example of Delhi, for about 4 months of the year, you cannot use a diesel generator in Delhi because the air pollution is so bad. So that's something that's running against the continuing use of diesel in the country. And the third big reason is something that both Vinay and Tobias talked about. Solar and wind, renewable energy is definitely cheaper than diesel power. It's cheaper than grid power as well. And more companies are looking to source their power needs from renewables, whether it's through rooftop solar or it's through open access that Vinay talked about. There's one more issue, which is more of an operational issue with diesel power. What happens is, let's say you have an outage and you lose power, and let's say it takes you a couple of minutes to switch over to diesel. You are going to suffer inventory losses. I mean, you may suffer inventory losses. You may suffer losses in efficiency. In the sense your people will be kind of sitting redundant without doing much while they're waiting for the power to come back on. And then lastly, you will have costs to restart as well. Now, if the power quality issue does not lead to an outage, and all it leads to is, let's say, a voltage drop, depending on the kind of equipment you use, you may still have an issue with batch losses, inventory losses. You will definitely incur a restart cost, and there'll be inefficiency, losses from loss of efficiency as well. And that's where battery storage comes in. What you're looking at is a Fluence battery storage solution. On the left, you're looking at a cube. That's the box that has the batteries in it. It's got the HVAC in there. It's got firefighting equipment in there, and that's where the batteries sit. On the right side, you're looking at the balance of plant. So what you have here is, besides the cubes, you have the telco rack, which allows you to communicate with the batteries. You have an inverter system, which turns your DC into AC power. And then you have a transformer that gets the power up to the voltage that you require, and then feeds it into your business, into your operations. And that's exactly what's marked on the slide in front of you. So this is how it sits. This is I'm showing you the slide of Fluence Edgestack, which is a ready to deploy solution for commercial industrial customers. It comes in sizes of 500 kilowatts and goes up to 3 megawatts. The duration of the system can be anywhere from 1 hour of continuous power to up to 4 hours. The voltage output of the system is 480 volts AC. And the number of cubes, so in this case, you're looking at 4 cubes. You can, you can keep increasing the number of cubes to get longer duration, depending on how long you need that power, which depends on what the duration of your power cut and your load shedding is. These systems are self-contained. They are cooled. They're water cooled. They could be air cooled. They could be liquid cooled. We have all those options available. They have a built-in fire suppression system, and the temperature range in which they operate is anywhere from -40 degrees C up to 50 degrees Celsius. And the battery chemistry is lithium ion. Okay, and what exactly do these batteries do? So what we do is we deploy the battery in parallel to your grid connection. So what happens is, these battery storage systems are always synchronized to the grid. So basically the battery just sits there, it's synchronized to the grid frequency. When there is an outage, the software automatically shifts the source of power from the grid to battery storage. And since it's already synchronized, you can be up and running in less than 250 milliseconds to feed the load. and this can go on for a duration of up to 4 hours. So that's how the battery would sit in your network and do things that your current diesel genset is unable to do. Okay, and there's one more benefit that I want to talk about is about your connected load, right? So when you set up your factory in India, you're going to find out what your peak load condition in that factory is, and then you're going to get yourself a connection for that peak load, right? Now that connection you have to pay the variable charge, which is the cost of energy, and you have to pay a fixed charge as well, which is the recurring charge that you pay on a per kilowatt basis per month for the whole year, regardless of how much energy you use, right? So what you will end up doing is so in this case, the example we are looking at, we've seen that in this particular day, the peak demand went up to about 20 megawatts, whereas the average demand is about 12 megawatts. Well, more like 10, but it goes up to about 12. But that one peak that went up to 20 megawatts happened just once during the day, right? So in this case, typically you would go with a connection of 20 megawatts. What you can do with the battery is, with the software, you can deploy the battery to basically shave off that peak. So at the moment your load hits above 12 megawatts and it goes up to 20, the battery will be sized to basically cater to that load. So now when you get your connection, you don't have to go for full 20. In fact, you can get a connection for 12 megawatts, and you can save on the fixed cost on the remaining 8 that is being served by the battery that is sitting there. So that, in a nutshell, was what the current scenario for backup power in India is, what kind of headwinds diesel as a backup power source is running into, and how battery can come in and play a role. And I also told you about the one project that we've done in India, which is a 10 megawatt 1 hour project, which is at a distribution company in Northern Delhi. Here's just my last slide. I just want to go over a list of, like a checklist, if you will, that you can use to determine whether, battery storage will make sense for your business or not. So one of the first things I would say is that you should have a connected load of 1 MVA or more. The second is, there should be a need for, you should be using diesel as backup or base load. And if that's the case, then battery would it'll be good to evaluate batteries. Your load profile should be peaky. So the kind of load that I showed you in the previous slide, that's a peaky load. You should be facing power cuts or voltage drops. And because of that, you should be, if there are added inventory and efficiency losses, then that adds to the business case. You should also look at what the demand charge is. So some of the numbers that Tobias and Vinay shared were just the variable charge numbers, but you should look at what the fixed cost for an electrical connection in where your factory is located is. And then you should, if you have plans for GHG emissions or reducing diesel use or lowering your GHG emissions, and if you, let's say, put a value on carbon, for example, then that will add to the business case as well. And then if you're looking to buy a new diesel genset or replace an existing diesel genset, then absolutely you should look at not buying the entire fleet that you're planning to buy, but definitely look at evaluating whether you should replace, if you're going to buy, let's say, 4 diesel gensets to kind of have some redundancy in the system. Look at if you want to include 1 or 2 BESS systems, and then maybe go buy 2 or 3 diesel gensets to start with. And then lastly, you absolutely need battery storage in this country if you want to build more resiliency in your electrical network and manage risks that are not within your. And that's the last slide I had. I hope you've had a chance to submit your questions over the chat box, and I think we'll take those at the end of the discussion.
Yeah, thank you very much, Rupam ji, for giving us detailed insights into potential business cases for storage, and I think there will be lots of discussion after. But